Hey everybody, welcome to our new unit on also on light, but now on the refraction of light. And I want to provide a little bit of background here at the beginning so that you have a better understanding of some of the key terms and concepts and fundamental foundational ideas as we begin to move forward into talking about the refraction of light. Before I get too far, let me just say that most of you have taken the quiz, or the quest, I guess, that was posted on Wednesday on the reflection of light. I would encourage you all to get on that and finish that up soon. I'm going to have it available from time to time, but if there is a particular time when you would like me to make sure you can have it available for you because of your schedule, please email me and we'll talk about that. So, getting on to the refraction of light. Refraction is a fancy physics term for bending. Refraction of light is really all about the bending of light. And we see this in a lot of different ways. And I'll be showing you some examples on some video clips of some common everyday occurrences of the bending of light, some interesting phenomena that I'm sure you're familiar with, but I've never really thought about what's behind that before. But I'll tell you right now, um, every day, every day there's an example of refraction of light, and it has to do with when sunrise and sunset occur. The light is bent when it enters the atmosphere in the morning and again in the evening, and actually throughout the entire day. And we'll talk a little bit about what I mean by that and how that works as we go through this unit. So the refraction of light is a really important, really an everyday physics concept. And we're going to start learning about how it happens and why it happens and how we can predict what's going to happen with the light because of some physical laws that we've learned about it. So why does light bend? It turns out that there are two requirements for light to bend. Light will bend because number one, it enters a new medium. When light enters a new medium, in other words, a new thing that it moves through, it either speeds up or slows down, but its speed changes. So one requirement is light changes speed because of a new medium. For instance, when light moves from air to glass, or air to water, or water to glass, or the vacuum of outer space into the atmosphere, that of course is our air, those things are new media, right? Outer space to the atmosphere, new medium. Air to glass, new medium. And anytime a wave moves from one medium to another, its speed changes. And light is no exception to that. Light speed will change anytime it goes from one medium to another, like air to glass or air to water. So that's one requirement. The second requirement is very important as well. It has to do so at an angle. And in order to better understand what I'm talking about here, I want you to think about something that maybe you've all experienced. If you've ever been to the grocery store and you've been using one of those big carts and you have accidentally, like I always seem to do, grab the cart with a sticky wheel, right? You're pushing it along and one of the wheels is bent or it's got gum on it or something else gross and it doesn't roll as well. And let's say it's the one over here, right? So the wheel in the front of the cart on this side doesn't turn really well. So as you're pushing it along, what's happening? Well, your cart keeps pulling in that direction. When this wheel doesn't work so well, your cart pulls that way. Well, why is that? It's because this wheel doesn't turn as fast. This wheel over here turns just normally because it's working pretty well. But this wheel doesn't turn as fast. So because this wheel is going slower, the cart turns in the direction of the slower wheel. Another example, if any of you have a car that you have to maintain, you may have experienced the fact that sometimes you're driving along and your car pulls one way or the other. Now, sometimes it's a major problem with your entire steering apparatus, right? You need a wheel alignment or whatever. But sometimes it's a simple matter as one of your tires is low. Because if this tire is low, and it's not turning as well on the road, when you're driving along, your car is going to pull in that direction a little bit because this one's moving slower. All right. When one wheel moves slower than the other wheel, the car tends to turn in that direction. The grocery cart tends to turn in that direction. Well, it turns out a very similar thing happens with light. And I'll show you an example. Let's imagine that this is a boundary between air and glass. And let's also describe this line, which is a normal line, perpendicular to the surface between the air and the glass, okay? If light approaches this boundary along the normal, it's gonna slow down when it enters the glass. It will slow down, but it's gonna go straight because the light is going straight when it hits the boundary. So if you think about it, both wheels slow down together. But if light is coming in at an angle, we'll call this an angle theta, and we'll call it theta 1 because it's the one outside the new medium. If light is coming towards a surface at an angle, then one wheel, yeah, I know light doesn't have wheels, but one wheel of the light, like the grocery cart, like your car, slows down first. Which wheel slows down first? Well, if it's coming from this way, the wheel on this side of the light will slow down first. So when it goes into the glass, and this is still the normal on the other side, when it goes into the glass, it bends in that direction. Okay? It comes into the glass at this angle, but it goes through the surface at that angle. And this angle here is smaller than that angle here. We call that bending towards the normal. So just like your grocery cart bends in the direction of the slower wheel, just like your car turns in the direction of the wheel or the tire that is a little low on air pressure, all right? If light hits a new medium, changes speed, at an angle, it will bend, all right, in that new medium. And in the case where it goes from air to glass, a faster medium to a slower medium, it slows down and bends toward the normal. Now, does it always bend toward the normal? No. That depends on whether the light slows down or speeds up. What does that depend on? We'll talk about that next week. You probably read about it in chapter 18, section 1, but we'll talk more about that next week. But for now, what you need to know is that light bends or refracts when it changes speed, or in other words, enters a new medium at an angle. And it does that for much the same reasons that your grocery cart turns when it's got a slow wheel, when your car turns when it's got low air pressure in one wheel. All right? Because the difference in speeds between the two sides of the grocery cart or the car, or the light waves as they're hitting this new medium, causes the light to bend in one direction or another. When it bends like this, we say that's bending towards the north. We'll take a look at a few more examples next week. I'll have some more videos for you, some simulations like we've done with the previous unit for you to get a better sense and a feel for all of this. But I just wanted to make sure that you were familiar with some of the terms like refraction, bending, changing speed in a new medium, at an angle, and bending towards the normal with two different angles, theta 1 and theta 2, theta 2 being smaller than theta 1. All right, we'll see some more examples next week. Thanks, everybody.